clean up what we have here. Let me reconnect this and let's try to clean up what we have here. All right. Welcome, Aziz. Aziz, we are glad to have you here. So let's start with Zipmap and Filter. Okay. I will just copy this and just copy selection so that I don't have to come back to that place, and I would paste that here. Okay, so let me paste this here and make them comments. So that way we get to pick them from here and begin to work on them. So the first we want to work on is Zipmap Filter. Actually, this belongs to the class of functions called Python built-in functions. And what they do is they're about, I think about 40 of them like that. They work with practically every object type. So they have a lot of things they do, and they have a lot of users, and we could actually have a full course on Python built-in courses because they help productivity a lot. So if you've seen the function called learn, that's an inbuilt course, it's a inbuilt function. If you've seen the function print, and practically every function that you've seen us use where we have to mention the function name before the parentheses, those are built-in functions. All right, so we have some situations where we probably want to, in quote, zip two iterables together. And if you have a good IDE like Colab, Visual Studio, whenever you put in the function, it tells you what the function does and the variables it expects. And so the first thing this one does is this one expects iterables. And what are iterables? There are things that you can iterate over. So it can be a list, it can be a tuple, it can be strings, it can be whatever, So what this does is it takes the first iterable and then it makes it run with another iterable merged together. So let's see how it works now. Let's say I have this, my friends, and let's say I have the names John, then we have James, and we have Jude. And then, so let's have your friends, and your friends' names are, say, Jeremy, and Jack. Sorry, Jack. Okay, so now if we want to zip these two iterables, what's going to happen is we are trying to, let's say we want to pair them for an evening brunch, let's say brunch, an evening get together or something. All right, so let's say we want to pair them, and maybe for a dinner or for a party or for something. Yeah, so what this does is when you put those two iterables together, like if I say zip my friends and your friends, and I run it, so it's going to tell me I have a zip object. And whenever you have a zip object like this, you can actually print it out in a list. So you can run this, and this is what it does. So it pairs John and Jerry, it pairs James and Jeremy, and it pairs Jude and Jack. So that's basically what zip does. You can run that over as many iterables as possible. It's just straightforward, you know. Well, like John noted, I believe that when we start doing the projects, we will show these things working in real life, so that it doesn't just look like, you know, where am I going to use this? So for map, we saw map last week. Map, what map does is it applies a function, all right, over iterables. And so, for example, last week we looked at the function called multiplier, and we applied it over a number of iterables. So that's how map works. Now, what does filter do? Let's see what filter does. Now, this is the filter function, and what does it do? It takes an iterable, all right, and it returns an iterator yielding those items for which the function is true. So if none, then return the items that are true. Now, let me see if I can do a Boolean array with filter. Let me see. Can I do a Boolean array with filter? Just a second. Filter. Okay. Let's see if I can do a Boolean array with filter. Okay, no Boolean arrays, so it's just function and iterable. Okay, so let's pick a function, and an example of a function is, okay, this is just an example. Let's just pick this. So what this does is it takes the ages of people in class. So let me just maybe use ages of pupils, and these are the ages, right? So let's have a function that tries to just check the ages of the people if any is an adult, and usually adults are 18 and above. So let's say, let's call this function find adults, all right? And what this function does is it takes an object, all right? And okay, maybe I should leave this out, but let me just, okay, so find adults. No, let's make it take an object, all right? So if, so let's say if, let's start with a for loop. For age in ages of pupils, if age is, say, greater than 18, okay, so what do we do if age is greater than 18? Okay, so if age is greater than 18, let's say print, okay, no, let's not print. Let's do true. Okay, let me see. What logic do these guys use? Return false, return true. Okay, trying to do, okay, instead of doing return false, return true, let us do, okay, let's do that first. Then I'll do the other one. Return false. Then else return true. Okay, so now so let me run this function and let's call this function with filter. So if we do this filter and we call this function on ages of people, because that's what filter does. It takes a function and okay, no, filter find adults. The function is find adults. And we call it on this ages of people, which is the iterable ages of pupils. Then let's see what it gives us. Okay, let's have this in a list and let's print it out. If age is greater than 18, return false, else return true. Okay, so there you have it. Logic is wrong. Now, okay, there is another way. Let me do this. Okay, so, okay. If we have this adults here, I'm gonna call this function. Let's see what we get. And then this creates an iterator. All right, okay, I get it. Okay, so this for loop, so for person in adults, this for loop would create, let me see, print person. Okay, so let me get this. Let me get this correct. Yeah. So this takes the ages, all right? 5, 12, 17, 18, 24, 32, and so, okay. Let's see. Okay, let me take this because I thought that would make, okay, if x not age now, which is what is in here, is less than 18, and oh yeah, I see the problem. Okay, so that's what happened there. So, okay, so this is it. First, I declare this age of the pupils, and then I declare a function that finds the adults. So, And what this function does is if the number that is in here is less than 18, then that person is not an adult, all right? But if it's greater than 18, then the person is an adult. So naturally, if I call this function, find adults, on this list called age of pupils, it's supposed to give me, okay, I think let me have this here. Let me add this here. Okay, so less than is not supported between instances of tuple and ints. Okay, tuple is this and integer is this. Okay, so should I make this a list? And let's see if that works. Let's see if that will work. Now, okay, so this was what I was trying to find out earlier, whether filters are going to allow Boolean arrays. When we get to NumPy, we're going to see something called Boolean arrays. A Boolean array is a way of looking at a list of numbers and then trying to find out if you can actually run a function that checks each of these and returns whether they are true or false. So that was what I tried to do to see if I could create Boolean arrays. And so it means we can only do this with NumPy. All right, so yeah. So that means I would not be able to call this function. So I'm just going to delete this. And yeah. So what this other stuff does is I assign the variable named adults to this filter function and ask this filter function to run this find adults function over the ages of pupils, and then use a for loop to print out the ones that meet the criteria for adults. So that's basically what this does. So that's how the filter that's basically what the filter function does, right? Then for the last function, which is map. Okay, we saw map last week, so that's it for built-in functions. Now let's look at how to unpack lists and tuples. So I'm going to use the same age of pupils, and or let me use this, my friends and your friends. So I'm going to use this, and I'm going to say if I want to unpack this list, my friends here, all right, what I'm going to do is I could unpack it in, okay, let me even increase the size. Let me make this another list called our friends, and let's make it a bigger list. So just delete this, and okay, so we have our friends, which is a larger list. So now let's say I want to pick out just the first and the last on this. What I'm going to do is I'm just going to say something like this. My first friend my first friend, others, and my last friend equal to our friends. Now, when I do this and I run this, this is what's going to happen. So when I say who is my first friend, Python tells me John. Okay, so then who is my last friend? And Python tells me it's Jack, obviously, because this is the last person. Then I have used this star operator here to make all of these other people come under the name others. So when I tell Python to print the people that fall under the name others for me, it's going to print every other person in the list: James, Jude, Jerry, Jeremy, and all of that. So what we just did here is called unpacking or partial assignments. Well, most people know it as unpacking. All right, so it's also called partial assignments. So yeah, so that's the name. So you can even decide to say, okay, you know what? I don't want this. Let me just comment this out. And let me create it here. I'll just delete this. So I could just say, you know what? I don't want to have just my last friend. I want the first person on the list to be called my best friend, right? And every other person would be called other friends. So in this case, when I run this, if I ask Python who is my best friend, tells me the first person on the list, John, which is this. And if I ask Python who are my other friends, then it brings out every other person on the list. All right, so this is the same, because of the star operator, this is the same thing that works when in a function, when we try to define a function and we say, okay, so def function, all right, and we put star args. So this same star here does the same thing. It lumps everything that you need to have. It just lumps it together into one. All right, so that's what that operator does. Now, there are some other examples that you could use this for, and let me see. Okay, I probably am going to try to look at some further examples much later. But let's touch one more thing, lists and dictionary comprehensions. So one of the things that we have seen in Python is that sometimes you want to create a dictionary. So you've seen us do something like this, results equal to this. So let's just put an empty list. And then we now use a for loop to say for, okay, maybe I should use, let me use this our friends. Okay, let me use this our friends. Now, let me put this here. So these are our friends, right? These are names of our friends. Then now we have, let me say my That is my best friend or my best friends. So I could say my best friends, if there's anything like that. All right. And I put a blank list. And then I could just say, you know what? For anyone whose name has a J and an A inside of it, those are my best friends. All right, just an example. So what I'll do, I'll use a for loop to populate this list of my best friends. And I'll say for, I could say for friend in our friends, all right? If the JA is in our friends, that's if there is any of our friends whose name has that JA, then my best friends, which is this, dot append. And what are we appending? The friend whose name has that. All right, so let's run this. And then let's call this my best friends so that we can see who and who make the cuts. All right, so no, it can't be an empty list. For friend in our friends, which is this, if JA is in, oh, I'm sorry, if JA is in friend, right, then append that. So let's see, good. So we have James and Jack. So yeah, so these are my best friends for this class, for the purpose of this class. So that's what we did here. But you notice that this took a lot of writing. We first had to create an empty list, and we now had to create a for loop with this and all of that. And we have like 1, 2, 3, 4 lines of code. But what if there is a way to make all of this happen in one line of code? And it's very simple. So how it works is what you call a list comprehension. A list comprehension is just a reverse for loop. So how it works is you begin with what you want to achieve, which is I want to create a list called my best friends. So I'm going to create this as the name of the variable. But instead of having a blank list here, I'm going to create a list, but this time I'm going to put a for loop, a reverse for loop inside of this list. So let's begin with what I want this for loop to do. Remember, I want the for loop to check, to append the names of people inside the list. So what I'm going to do is I'm going to say my best friends dot append, all right, friend, okay? Or some people might prefer to use X, all right? But this is just what it is. I will append a friend name, okay? For friend in our friends, if JA is in friend. And when I run this, and I tell Python to print out my best friends, it's going to give me the same thing. None. No, can't be none. Okay, so my best friends dot append friend. for friend in our friends if JA in friend. Okay, let me see. Let me remove this and let's see how it works. No. Okay, where is the problem? So my best friends would be it's okay, so let me see if I change this variable name to, okay, let's do this. Friend in our friends if JA in friend. All right, so my best friends would be okay, let me see. Friend for friend in our friends if JA is a friend. Let's see if that works. Ah, yeah, okay, so this is it. So the way it works is this is what we want to achieve. We want to check for each of the friends and friends if JA is in friends. But because we're making it a list already by putting this inside, when I put that best friend on append, it's brought out that none. So all I just did was just to call this same thing that we are going to loop through, which is this iterator, and it puts each one inside the list for us. So for every friend in our friends who has a J name, that's what we want. So that's why we have that friend for friend in our friends if J is in friend. It's confusing, right? Okay, so maybe I would try another list. So let me take a list of but does it look confusing? Does anybody have a question on this? Okay, Tima, you're just coming. Did this look clear or it's a bit messy? Tima? Okay, cousin is great. Yeah, hi. Is it a mess?
Hello.
Is it, yeah?
Good afternoon. How are you today?
Yeah, I'm fine, Tima. So did this make any sense at all, or do I need
It
to?
does, of
Okay, it does, right?
yes.
Okay, cool. Means I'm safe. Okay, I know John is a guru already. We saw some of the books he's reading already, so I'm not going to ask John if because this is kindergarten stuff for John. All right. Okay, so let's just go on.
I understand the shortcut. At
Right.
this point, if I were to write it, because I've not had any situations where memory is a problem, I would still use the separate for and if statements as you've got in the first portion of the example. Just
Right,
because it's
right.
easier for me to understand.
True. Yeah, cool. And that's the whole thing about programming. You do what works for you, and yeah, every other person will have to bend to your code, as long as it's not bad practice.
As I do more and more, I may understand a lot more of these shortcuts.
Right.
But for right now, it's still readable as you've got up there in that first half of the example.
Right. Okay, so that's for lists. You can do the same thing for dictionaries, and that's what you call a dictionary comprehension. But I would not bother doing that right now because I really want to do these generators and ensure that the session terminates before 4. So let's talk about generators. Again, some of these things are things you might not need, but it's just like a good to know, so that in case you come into a situation where you have to use them, you could use them. So let me give you an example. Let me say I'm trying to build a robot, and the robot, what it does is it gives doses of drugs, right? So so let me say the dose would be say for morning would be 2, or it just recommends doses, right? So 2 in the morning, 3 doses in the afternoon, and 1 dose at night. So just 1 at night. Now I could always make this a dictionary, so that I could say morning 2, 3, and 1, but I just want to make this a list just for simplicity. So now if I want to write the program in such a way that, okay, let me do it this way. If I say for dosage, or for dose, like in dosage, all right? Not on this, that's why it's not recognizing it. Okay, so for dose in dosage, then return dose. Return dose. Let's see. Return can only be used within a function. Okay, let me say print dose. Okay, so print dose. All right, so this should take away all the squiggles. Okay, so it will just run these 3 at once, 2, 3, and 1. Now, this is not what I want. I want that when it's morning, the robot checks the time and then says take 2. When it's afternoon, it checks the time and then says take 3. And then when it's night, it checks the time and says take 1. All right. So one of the ways you can go about that is called a generator. Now, this is what happens. Every list tuple, or whatever you call them, objects, have a method called the iter method. So let me just run dir on dosage. All right, and it'll bring a list of all the methods that are available, all the properties and methods that are available in this object class. So Python has looked at this dosage and then like, okay, it's a list, and these are all the objects that are available. So you would see one of these called the iter method. This iter method is what allows Python iterate over the list. All right. So I'm going to call this iter method right now outside of this class. So this is what I'm going to do. I'm going to put this iter here. And by doing this, I'm overriding this internal iter that comes with this. Just watch what happens. So when I run this, now this dosage stops being a list. If you try to check what it is, Python will tell you it's a generator. And what's the difference? Because I've just used this function call here to override the initial iter here. If you look at when it was just a list, because I've not run this right now, when it was just a list, if you look at it, it didn't have a next method. There was no next function, no next property or method there. But when I run this now, that it's now a generator because I've overridden this internal iter with this external function call, see what happens. It has an iter now, and it now has a next inbuilt function. So what has happened is that Python has changed this stuff from being a list to being a generator. Now, what's the difference? I'm just going to show you in a couple of seconds, and let me just close this output. So let me say I write awesome line of code to get the robot to check the time. And then, so once the robot checks the time and all of that, all it can do now, I'll just tell it, okay, so print the next dose, the next dosage that we ought to administer. All right. Then I write another awesome line of code that tells the robot what to do, and then print the next dosage, and another awesome line of code, and print the next dosage. So see what happens. So I run this, and then it tells me, okay, so the next dose you should take is 2. And then the next dose you should take is 3. And the next dose you should take is 1. So what has happened is that because I've created this as a generator, Python stores the last state of what it administered, right? So when I say next dosage, it tells me 2, and it stores that internal state inside of its memory, waiting till the next function call for this dosage. So when I call the next dosage, it returns 3, and then it stores that, okay, I've administered 2 doses. It waits for the next function call, like that. So it keeps doing that until you state, say, okay, so if I just put next, because we have exhausted the number of items in this list, watch what happens. It will give us a stop iteration error, because I mean, it has exhausted all the stuff in that iteration. So we'll have to write an error catching code to trap this from happening so that our robot does not shut down whenever it goes beyond the iteration. So that would be like maybe a loop that would move it back to the previous state or something. I don't know. Depends on what we think about when we're writing the code. So that's what generators do basically, right? It can be a generator. It can be something that picks out people in a list. It can be something that's anything basically that has to do with picking out people one by one, or picking out things one by one, or picking out anything. So when you have to do that, you really do not have to use a for loop or use indexing, because some people would rather do indexing to say, okay, instead of doing this, they probably are just going to say, for the first one, awesome line of code, instead of doing this, they probably are just going to do, give us dosage 0, and then dosage 1, dosage 2, like that, or use a formula like len to try to find the boundaries, stuff like that. But hey, sometimes just having generators save you the stress of having to do a lot of indexing, you know. And if you're building a function, you can just pad the generator inside the function and just go to bed, and the function just keeps generating until it's done. Obviously, you have to attach an error catching try except line of code, block of code inside of that. So that way you don't get to have a lot of stress, you know, when you write the code. So that's how generators work. Like I said, nice to have, but the use cases in real life programming, well, not much, unless you're really doing like robotics or what do you call it now? Well, some part of AI, especially self-driving cars and all of that. Yeah, so there you have it. Questions, contributions, queries, annoyance, reprimands, and all of that, please. The floor is open before we call it a day. Any?
I just want to say thank you. Like every time I keep coming because I get value every time I come here. So thank you very much for your consistency. God bless you.
Thank you, Aziz. Amen. Thank you. Thank you. Okay, so for some of you that did not join earlier, we are trying to tweak the format of the session. So we're trying to create a curriculum. What would work? What do you think you would like to see in the next, like, if we're going to continue running this introduction to Python class, what format would you like it to be like? Right. So that's what we're taking. And please, really, I don't know if I should create something like a Google form or something. You know, just want to have feedback. So we've gotten awesome feedback from John and from Kasim because they were early in class. But I'm going to try to make sure this feedback form gets to you guys if you prefer it in that format. But if not, you could just chat me up and say, okay, so I think that we should have this, this, and this. You should take this form. You should take this other form. And then we would be glad to consolidate all the suggestions we get and see what we can make of it. All right. But while we'll wait for that to happen, for next Saturday, what would you like to have? What would you like us to touch? I'm open to hear that right now, and we could touch it next Saturday. I could make it into like a wish list, pending when we finish building our curriculum, and then. So since this is what you guys wish to see, we'll do it next Saturday. So please, anyone can. You could put it in the chats. What do you want us to have next Saturday? Because like I said, I don't want this to just be like an exercise every Saturday. We just come together and then just no. I want it to be impactful. I want it to be solving a problem. I want it to be doing something and helping you as much as possible. So whatever it is you like to see next Saturday, please put it in the chat. And I promise you we're going to do that next Saturday. Anything at all, anything.
Sorry, I don't know, maybe you already touched the web scraping, but I know when I just came in today, I saw something about web scraping. Okay. So did you do that?
Okay, so let me note that web scraping. I'm creating it as a wish list of things that would have to touch. Okay, so next, any other person?